Okay. I had in my mind that we're going to do some reading in the books. I changed my mind. We'll perhaps do that tomorrow, along with you have a vocabulary evaluation, the only one, of course, for this chapter. And that's tomorrow. Okay. And with that, when we look at what we've covered so far this semester, of course, it was digestion, and then it was the nervous system. Now we got the endocrine system. And I was thinking about this this morning. I don't know, let's see, how can I state this? I would think you'd believe that we have covered a lot of information on account of when we're talking about the nervous system, we didn't break it down into one port. We had one big unit with that, okay? Because we include both the peripheral and central nervous systems with this. And now we're going to wrap up what would appear the endocrine system maybe on Friday. I don't think we're quite going to get there. So with your semester exam, that will be over the endocrine system and some other materials that we may place into that, but we'll certainly make you aware of that before that time actually gets here. Okay, so we are winding down fairly quickly. Mr. Hemmer had sent out a schedule for that, and yours is, I don't know if we want to say right away on Monday, the second one of the day in that morning. With that, let's go ahead and continue with what we have talked about so far. Can someone give me an example of a tropic hormone? Now, keep in mind, tropic means, you could say, means target. So what would possibly be a hormone that would be the second message, for instance? Okay? You could use water retention as an example. You could use growth and metabolism of carbohydrates in lipids and proteins like we discussed yesterday as an example, which is probably the best one to utilize. So what did we discuss yesterday? You're going to say, I knew that. We have talked about that, and that probably did come up yesterday in a separate question. That would be hormones that counteract one another, the gastrin and the cholestocinin. But yes, we did talk about that yesterday, but that would not be a tropic hormone. Use this guy as a pathway. Oh, don't want to lose this. Need that in the chemistry lab. That's what's strange about this shirt. I keep forgetting. Wife bought it for me. No pocket on it. What does she know? She missed that. I say, you missed this! No, I wouldn't say that. Still looks good, I think. Although, got tiger jumping up and down. I don't know if the orange looks very good. I just picked a tie. Anyway. Okay, tropic hormone. Okay. What do you suppose the parathyroid hormone's going to stimulate? I'd said that wrong. The thyroid stimulating hormone is going to be a first message looking for where? Because it's coming from the anterior pituitary gland. The first message leaves, and it's going to go to the thyroid gland. That's the first message. The second one would be the tropic hormone, and that would be for what specific hormone? Thyroxine. That is the tropic hormone. That's an example of that. Because what is that thyroxine going to do? It's going to help regulate breakdown of what type of substances? I heard carbs, which carbohydrates, proteins, and lipids. It's going to help regulate that metabolism. Okay, so this is not a type of negative feedback mechanism to where it's when you look at this, you could really say that thyroxine is just really monitoring itself, because as it's coming from the anterior pituitary gland here, okay, it's shooting out all of these different types of hormones, and then here's your thyroxine, and then the amount of levels in the blood, that's just going to be a continual loop to come back up here and say, okay, you can slow down, we don't need as much thyroxine then. It's kind of like your waters that have a float in them. When that goes down, you get more and more water coming in. That eventually goes back up again. Once the float gets to the top, shuts it off. This would be kind of a similar mechanism. So once this is where your horses or cattle are starting to drink, levels are going down, so you're stimulating and pushing out more and more thyroxine. Okay, now we're going back to this loop. It slowly comes back up, sends a signal, okay, shut it off. We don't need any more thyroxine. And it just kind of goes back and forth and back and forth. So the thyroxine really regulates itself, okay, if that makes any sense, because once it's no longer needed, it stops. Okay. So, can someone give me an example of another type of hormone, and what does it do? Come on here. Oh, I know what's not working. Let's try this. Can someone give me another hormone, and what per se does it do? So we know what parathyroid, or we know what the thyroid stimulating hormone, or TSH, we know what that does. We know what thyroxine does. What's another hormone? Okay, the parathyroid hormone, what is that going to stimulate? They're little teeny tiny glands on the thyroid gland. So it must stimulate these little tiny pea-sized glands called the parathyroid gland. Okay, all right, I think we'll talk about that today. Okay, because I think that's, oh yeah, we did leave, right there, parathyroid hormone. Okay, yep. Okay, did we talk about this slide? Did we talk about the blood phosphate and calcium ion concentration yesterday?
I don't remember talking about
Oh, okay, but did we write it down?
Yeah.
Oh, we wrote it down, we just didn't talk about it. Okay. Then what I would like to do then is, okay, talk about this. Okay. This is a type of, you could say a negative feedback mechanism, because it's what counteracts one another. Because we've seen this before, okay? These top two we've already talked about, so I wouldn't write them down, but this is entirely up to you. You could say, well, we're going to just use two examples. We had insulin on one side and then glucagon on the other. I was going to say gastin and cholestokin, but let's not throw all of them into here. So we've seen an example of this, okay? Then the next one If you choose to write it, fine. If not, we've seen a prior example before. So, parathyroid hormone, okay, or PTH, okay. We'll just go ahead and put this dotted line in here, okay. If calcium levels are high, we're talking about calcium ions now, okay. As these levels go up, there has to be a way to get that back down to a normal level, because now, just like the sugar levels get out of balance, so can your calcium ion concentration. So once that gets elevated, okay, there's a hormone called calcitonin, okay. So what that does, rather than just understanding the entire physiology of all of this, the way that I like to explain it, because I think it's sufficient enough for this level, next time you see this, with the exception of yourself and yourself, you're not going to see this ever again. Not programming computers or something to that effect. But to me, this makes sense. Now, the next level you see this, you might have to be able to describe, okay, if this ion level is elevated, how does this get back into the bone tissue? Well, we're not too concerned about how it does that, but rather what this does, okay? So if calcitonin is a hormone that deals with elevated levels, okay, well then this is going to bring it back down, okay? But if our calcium levels here are too low, well then what we want to be able to do, because it's dropped down, is we want to be able to go that back up. The reason we see a dotted line and a solid one is that's returning it back to a normal level. That's what we're trying to illustrate here, okay? So calcitonin deals with high blood calcium levels. So what it's going to do is force that calcium back in to the bones. So since it ends in calcitonin in, this pushes the calcium ions back into the blood. Back into the bones, sorry. So if it's forcing your bone tissue to absorb this, what's this level here going to start to do then, would you think? Yeah, so now we've got this dotted line, it's going to bring this back down to a normal level, okay? So there has to be a way to regulate that, because if your calcium ion levels are too low now, okay, we need to be able to draw that back out of your bone tissue to get this back up to a normal level. So calcitonin pushes it in. It's this that draws it back out. I'm not going to spell it out because that's a big long name. What would you guess this is? Parathyroid hormone will, and maybe you could look at it this way, pulls this out of your bone tissue, pulls it out, pushes this back up to a normal level, okay? Then when we look at when calcitonin, when your calcium levels are too high, it forces it back into the bone tissue. I don't know if that helps, or hopefully that makes somewhat of some sense, we hope. Okay. So it's very similar to what we were talking about here. I don't know if this diagram looks similar to what we did with the insulin and the glucagon. The idea is the same, it's just different substances and different hormones. All right. Okay. Can I pull this screen back down? Okay. So then moving forward, we're not going to do a whole lot here. Okay, so parathyroid glands, parathyroid hormone, it increases those blood calcium ion levels. Calcitonin then actually lowers it then. Raises calcitonin in, pushes it in, so it comes back down. Okay, the adrenal gland, okay, which we know sits right above the, well, I don't know if you know that, but that's where it's located, is right above the kidneys, yes. Okay, so as you can see, there is one hormone that's left out that has a similar function to this. There's one that actually increases it even more, if you want to call it that. But that's not listed up here. That is certainly a hormone. So if it's not epinephrine or norepinephrine, the reason we say that is those two hormones, epinephrine and norepinephrine, are amino acid based. Okay? So there's another hormone that does something similar, but rather it's a steroid hormone, and that would be what? It would be adrenaline. That's right. Okay? So one of the things that we see happening here when we're talking about if you're stimulating muscles like these two here, heart rate, that's definitely a muscle. When we say breathing rate, it doesn't have an effect on the lungs because the lungs are not muscular tissue. It's what drives the lungs. Yeah, it's actually your diaphragm that's a muscle that drives this breathing rate. Okay? So if this actually causes these to increase, which it does, okay, do neurotransmitters, let's say, travel a long distance? You got a 50-50 chance. Remember we talked about something called a synaptic knob, the synapse. What is the function of neurons? They transmit signals between what two types of structures? Either neurons to nearby neurons or neurons to the neuromuscular junction. What must it be stimulating? That's your clue, neuromuscular junction. What must it be stimulating? Well, what these are, we said. The heart and the diaphragm are both what? What type of tissue? Muscles. So in that neuromuscular junction, it's those neurotransmitters that either stimulate other neurons or muscular tissue. Does that have far to travel? The entire distance from your brain to your legs, yes, that might be a long distance, but the neurons between one another, is that a long distance? No, very short distance. And does it last very long? No, it does not. Hormones, on the other hand, okay, when we're looking at, for instance, your parathyroid hormone, that travels all throughout the body because it's pulling all that calcium ions out of your bone tissue. Or you could say calcitonin, pushing all of that calcium ions back into your bone tissue. That occurs all throughout the body. That is a long way to travel. And does it short or long term? Does it last very long? Like a synapse. That's a synapse. Didn't last very long. Hormones, on the other hand, travel long distance, and they can take a long time. It can be hours, for instance, sometimes even days, depending upon what type of hormone. Okay, I believe that's where we want to stop. I want to see, I know there's more content for the adrenal glands, okay? Want to do that one on Friday, that one, and then we'll get to the pancreas because we are winding down pretty quickly, okay? We'll do our best to wrap this up on Friday, and then we'll start our reviewing for what we think is important for your semester time. Okay, vocab quiz tomorrow, and we'll catch up to you next time.